Hey guys, long time no see. It's been a really nice hot dry summer here in New Zealand, so I've been spending quite a lot of time surfing and kayaking and getting out and doing stuff, and so with winter now approaching, it's probably time to get back into a bit of refining. So far for the year I've only got about half an ounce, which is not looking very good, but back's a bit stuffed after a day of kayaking. So I figured today would be a nice day to get back into a little bit of refining. So my victims of choice today was some of these. I had quite a few of these that I'd harvested from very old avionics boards, and what they are, we get a bit of zoomage going, they are little digital to analog converters. I'm not sure who makes them, see if I can see a name on them somewhere. Looks like they're made by Analog Devices. If that wants to focus, there you go, AD394KD. And so they're little ceramic packages, obviously have plenty of gold plating on them, and they've unfortunately got these stainless steel lids, which are a little bit of a pain in the ass because I have no intention of dissolving away truckloads of stainless steel. But luckily they're relatively easy to remove, and I'll show you how to do that in a minute. Now, I wasn't going to do a video about this because I didn't think there would be anything particularly special happening here. I'm going to pull off the lids, dissolve away all of the gold with aqua regia, neutralize, precipitate, all the regular kind of stuff. But when I started removing the lids, I've got a few lids here, and you'll see they come off relatively cleanly, so there's no gold lost, basically getting rid of those stainless steel lids. When I started removing the lids, let me zoom out a bit, you'll see I've got a few there, and I'll count them before I get going so you guys know more or less what I'm doing with. What I'm essentially doing is I'm just separating off using a knife the stainless steel lid, but sometimes if we look very carefully, I'm not sure how I'm going to get this to happen, there you guys can go. If you look very carefully between the stainless steel and ceramic, you've got a little bit of gold braze that holds the lid to the ceramic. And what happens sometimes is when you split off the lid, it separates on the ceramic side, so you end up with that. So you end up with the little IC, and you can see lots of little gold bond wires and things in there. But the gold braze comes off of the lid. And when you actually peel the, oops, let me show you one here. When you actually peel the gold braze off of the lid, you end up with a remarkable amount of gold here. Like I assume at this point, and assume's not a good thing to do, but I assume that this is relatively gold. And if we look at this, so keeping in mind that each one of these little ICs will have one of these, if we look at that, then we're dealing with 0.79, almost 0.8 grams from each one of those ICs just on this braze that holds the lid to the ceramic. And so yeah, that's why I thought I should probably do a video of this, because it might just be the best e-waste I've ever processed. If that braze ends up being not predominantly gold, then it's not going to look anywhere, not going to look very spectacular doing a small amount of those. But once I've decapped all of those, it's only going to take up a very small amount of space in the bottom of a beaker. So yeah, I'll run through these and we'll just see. That might be the best e-waste ever. Okay guys, so the first thing I tend to do is obviously put some gloves on, because we're going to be working with a knife here, and surprising how good just even basic gloves are at preventing little cuts. Fold the legs in so they don't get caught on the gloves or cause any problems. Tend to put that down like so. Now I'm using for this a little bait knife for fishing. The reason for that is that the steel and bait knives has to survive salt water, so it ends up being pretty crap steel. And the nice thing about crap steel is it's not super hard, so when we basically try and hit on that, we're not going to smash the knife or anything, or take big chunks out of the knife. Even if we do, that's like $5, so it doesn't really matter much. So I'm just going to try and do this on camera for you guys. Hopefully it works. So I kind of position the knife on the little bit of gold braze there, give it a bit of a whack. Okay, so for this one, the the gold braze is actually coming off on the lid side, as you can see there. So peel that off. If we're lucky, there you go. Okay, so that peels off quite nicely. You can see the gold braze there. That bit goes up into the beaker. And now the only thing left to do is I grab some little side cutters for this. We're going to peel the gold braze from the stainless steel. You can see it's kind of started separating through there. So once you got it separated, it's not really that much of a challenge. You can just cut through that and then just start peeling. So it does actually peel off of the, I have to use the side cutter a bit. It does actually, so just can opener style, just when I peel it off, it does actually peel off surprisingly cleanly, even if there's a little bit of stainless steel that gets stuck on the gold braze that we want. It doesn't really matter because we got rid of all of the stainless steel that we don't really want to muck around with. There's probably a tiny little bit of gold left on that, but it's tiny. It's really not worth the dissolving of stainless steel. Okay guys, so I've got those digital to analog converters sitting in some hydrochloric acid here that's warmed up. You see there's a bit of a green color there. That's the hydrochloric dissolving some of the existing base metal. One of the things seen here is I've also moved on to having a little catch container, just from using the normal just kind of insulators instead. Very nice. Like I bought this for about $1. If you look on the bottom when you're on the thrift shops and it shows that it's flame safe and stovetop safe, then it's generally going to be quite good. To test this one, all I did was I heated this up as hot as my little oven would go, took it out, held it at arm's length with some safety glasses and a pair of thick gloves, and then dumped a glass of cold water in it. And if it survives that's just amazing. So yeah, like, you know, when we're dealing with what could potentially be quite a valuable solution there, it's a bit of a no-brainer. So I'm going to start adding a bit of a bit of nitric acid now to dissolve the gold, and yeah, be back with you guys a bit later. Okay guys, I've got the gold dissolved off those 22 ceramic DACs. And just a little tip for those of you who haven't worked with ceramics before, it is very common with ceramics that you end up with too much nitric acid in the mix, unless you're willing to go very slow. The easy way of dealing with that, rather than try and neutralize a lot of excess nitric acid, is to just decant your solution, wash your chips out with some water. Sorry, I'm a bit hidden in there, like we're working here, and get yourself a nice copper bar. Heat the solution up once again to about 60 or 70 degrees Celsius or so. Let the gold cement itself out on the copper, while at the same time using the copper to basically consume the excess nitric acid. You just can basically leave this thing just running by itself in the fume hood. There's nothing really much to go wrong here. Heating up makes cementation always go much quicker, so you definitely want to put a little bit of heat into it. Yeah, so I'm just going to leave this now. You can see that copper is nice and black with the gold, so it's basically just come back and give this a stir every now and then, and you'll know when you've done, because you'll clean the copper off or give it a spray with a wash bottle, and there will be no further gold cementing out. And then yeah, after that we'll go and just do a re-refine on that gold and see what the results are. Okay guys, so it's been an hour or so with heat and the copper in that beaker, and I've just got this set up to show you guys what we've got now. So as you can see there, we've got a reasonable amount of gold that's been cemented out, and so what we're going to do now is just let that all settle properly, and then siphon off the barren solution, obviously testing that with some stannous chloride, and then it's going to be the second refine. Cool, so we'll see how that turns out. Hey guys, so I've got the results here from our 22 little digital to analog converter ICs. These came out pretty clean for the most part. These have all been washed. You'll see the dies are still tend to be attached. They appear to be glued on rather than gold brazed on, so they didn't really come off. Some of them obviously must have been I'm not sure, soldered on or something, because you'll see they come off completely. But the majority of them, when I look at them sideways, I can see that they are they're glued on. Now 3 of these had some kind of red glue over the ends, which means if I peel that, you'll see we've still got a little bit of gold braze sitting on there, but that's no big deal. I'll clean those off and run them with some more of these ICs I've got to go. So we've got 22 of those. Shouldn't have counted my chickens quite so quickly, because I don't think we've got a ton of gold there. But there's something at least, a little bit for Easter. So yeah, let's get it on the lie detector and see what we've got. It'd be nice to see what those things are worth each. There we go. Yeah, got that. And I've got a little brush I use for just loosening it all up. It's looking good. We'll zero that off. And let's see what we've got. So 22 of those ceramic digital to analog converters gave us just short of a gram, which not quite what I was hoping for. So it suggests that even though that gold braze was looking very impressive, there wasn't actually that much gold in it. So if we go 0.96 grams, sorry, just working on this side, 0.96 grams divided by 22 units, we've got about 0.044 or so grams per unit. So yeah, probably only worth $2 or so each, those things in gold. But, you know, didn't do it, wouldn't have known. Unfortunately, I won't be retiring anytime soon. So yeah, that's how it crumbles sometimes. Anyway, good to see you guys again, and yeah, happy refining, and see you next time.